today. I'm gonna try. We'll see. Okay, cool. With that being said, let's kick off the stream and let's go. Welcome to Natural Education. My name is Dr. Gold. Stream that helps you out with math homework, science homework, all sorts of fun stuff. Looks like we were doing some trig here earlier. Let me see if the YouTube stream's working. Always a struggle sometimes. Let's see, we got a stream up? We do. Nice. We have connection. Do I dare try to see if TikTok will load as well? always a gamble. It's always a gamble. We're gonna try. I'm gonna try it. Go live. Okay, I think apparently we're live on TikTok as well. Okay. Let's see. Where is Sir Equity? Sir Equity had like some good questions, and these were similar to. Oh wow! Thank you, Wazcan. I appreciate the donation, dude.
That's dope.
It's a G move, dude. Thanks, dude. Appreciate you, dude. Where'd you find us? First time chat, and you dropped me $5. I'm a big fan of that. You wanted to ask a favor, actually. Oh, okay. What do I have to do for $5? I mean, $5 is $5. Okay, what's up? What's up, Waz? You're doing a research for a Master's of Education. Very cool. Oh, did you send me a DM, dude? Yes, you did. I just saw your DMs. Yes. I'm not going to out your real name, but it starts with S. Cool. Yeah, I'll respond to this. Do you want me to do anything right now to respond to you? Or do you want me to respond to this later tonight? That's cool that you're doing a Master's of Education. You have like a formal degree in education. I just have a PhD in physics, which is like, you know, the education kind of comes as an experience type thing. But Master's in Education means like you're actually studying the science of education. Whenever it's convenient for you. Okay, I'll do it this weekend. I was grading final exams for my UCLA class last night, and I think they're all done. So if you're watching from my UCLA class, your final grade should be basically done at this point. One sec, let me select my live sources. Maybe doctor one day. Yeah, you could be a doctor of education, right? And that's a whole thing. Doctor of education. Yeah, I see you got like a survey and stuff. That's cool. I really appreciate data, and I think you're talking exactly about what I'm talking, or what I'm literally doing here. I think just from briefly going through your DM, it's something about like tutoring via Twitch. Yeah. Do you want to just like schedule a call? It would be easier for me to just say this to you over an interview versus like type it all out. I mean, I can type it all out, but it's just, you know, human interaction is pretty cool. Yeah, I mean, tutoring is amazing. I mean, there are lots of studies on like how crazy good tutoring is. Why is my stream not activating? Activate. No. Activate selected, please. Thank you. Yes, Sibley, you can. Yes, totally can. Okay, cool. I mean, I'll tell you straight up. A lot of the students are here because they find me via different like tutorials and stuff that I do on Twitch and TikTok. Also, we give out like prizes and stuff for them watching and asking questions, so they're incentivized. Some people come here literally just because they need help with their homework, but I would say a good majority of our audience comes from like TikTok and YouTube and like running like contests and doing fun things that get students involved. But I'll fill out your survey, and then I'll see if the students want to fill it out. Yeah, sure. Is the survey for the viewers? Yeah, that's Drew. That's what Drew Taylor's asking. Huaz, if you can see it. It is the same link. It really is. Yeah, it's the same link. Huaz says yes. Okay, cool. I'll make an announcement in my Discord Well, let me like read through the survey first, you know, just to see like what you're asking. And then yeah, I'll I can make an announcement in my stream. I can also incentivize the students because like we have like a whole like currency within the Discord, and if I run like contests and things, students are more likely to fill things out. Let me activate this sword source. Let me see if this one works. Like what you're doing here. Appreciate it, dude. Nice. One sec. I gotta. What do I have to do? I have to like match the doggy up. Excuse me. There we go. Nice, Jeff. Jeff, you happy we're streaming again? Can you just quickly explain forces? What do you want me to explain about forces? My mind is broken. I also wonder why I'm here sometimes. That's too funny. Yeah. I'm trying to debase your currency by earning it, but not actually using it. Oh no, dude, Jeff. Okay, let's see. Let's see if we got some questions for today. I will count the questions you guys submitted on Wednesday. Also, things to go through. Where's Equity? Is Equity around? Equity's got to go. What's good? It's good to see you, 1K, dude. Where's Equity? Nice. And then Taylor, you got a good question as well. With it looks like something here. Taylor, I don't think I've ever answered a question for you, so I'll do yours first. Also, because I know Shantrixes scare me. I will do your Shantrix soon, but whenever I see probability in Venn diagrams, I get a little like scared. Okay. So this question is: a student conducts an experiment to determine the density of a known material. Use the data collection from both trials to calculate the percent difference. Yeah, so you don't divide them necessarily. What's up, mates? So if you want to ever do like percent change, percent difference, they're all the same thing. So percent difference, which you could also think of as like percent change, because you're going from like, let's say like one trial to another trial, like a different point in time. Yeah, no, I'll figure it out for you. It's okay. It's okay, Drew. So what you always do is you do like final minus initial, and then you divide this by initial. And then you multiply by 100. Yeah, and if you do those things times by 100, you'll get the percent difference is what it is. In this case, you know, trial 1, I think we kind of assume is the initial. And we assume this is like the final. In this case, though, it's higher over lower. Is it? Jeff, you might know that better than I do. Is it always higher over lower? Higher minus lower. Let me double check. Let me double check. Well, it does for like what you divide it by, though, right? Because if I do higher minus lower over lower, that's different than lower minus higher over higher. Let's see. You know, they really also. I don't know if I like the new ChatGPT differences. I don't like what they did here. They took away all the models. There's literally just like GPT-5 and like GPT-5 with thinking. Like, what happened to research? What happened to 4.5? What happened? There were so many cool models that I liked using. And now they just buffed it. Yeah, I would complain too, dude. What? This is like the fucking iOS of AI, dude. What? This is why I don't use an iPhone. They just dumbed it down. Like it was kind of. I understand it was confusing with ChatGPT to have so many different models that you could use, but if you were intelligent, you started realizing like which one was better for what things. Now they just say, "Oh, we just have this generic version, and we'll tell you which one it works better for." And I'm like, but you're not always right. Yeah. Let me see. For percent difference, how do you, which trial to divide by on the bottom? I'm going to use the thinking one because I don't trust the not. Why would I want my AI not to think? Excuse me? I'm just mad they got rid of deep research, really. Deep research was really cool. I was using it, starting to use it a lot. Oh, you divide by the average of the two, Jeff. That's actually pretty cool. I didn't think about that. Yeah, that's pretty sick. Yeah, that makes sense too, right? Yeah. So, I mean, Drew, this depends on your class. This is kind of this is what I was talking about, final minus initial over initial. Because usually, yeah, you're doing, right, new versus old, right? Final minus initial over initial, which is the old one. Or you can do it by, like, if it's like experimental difference, it's like measured minus theory over theory. Do you know any jobs anyone can apply for as a math lover? Oh, yeah, tons of jobs. Anything in finance. Loves math. Although don't go to finance. That's the dark side, man. What? I would say, yeah. Well, it depends like what you like to do with math. If you like to teach math, I mean, you could always be a teacher, or you could always tutor. You know, that's kind of what I did. But they always need math people. Depending like what types. If you love like linear algebra and vectors and matrices and all that stuff, computer programming people will like take you up in a second. I would say getting an internship first in probably something math related is your best way to figure out how to get it. I don't know if it's very easy to just get a job anymore these days. Just like straight up, just walk in and be like, I would like a job, please. You really have to know someone or have some sort of experience first. And the only way to get experience is, you know, it's like a chicken or the egg thing, is sometimes to like work for very free or very cheap. Yeah, for not a lot of money. Yeah, it's hard. Trust me, like, I'm about to be unemployed. I already am unemployed technically right now. And then UCLA just got hit with a $1 billion lawsuit by the Trump administration. Like, excuse me? Is this man okay? I don't know. The world's crazy, dude. Okay, so, but Drew, you said you can't ask your teacher. I'm just really winging everything, so I don't know what would be preferred. I mean, I think this is a cool way to do it. Divide by the average. I think this is a cool way to do it. I haven't seen it before, but you know, you could try it. So in this case, and you're right, the percent difference, if you're not saying that like there's like a treatment, like trial 1 is getting treated with something and then you have like trial 2 happening, if there's no like preference in the order, you do want the percent difference to be like an average, to be an absolute value. Anti-slap laws? What's anti-slap laws? You think it's like mean and standard deviation? Okay, cool. What are the slap laws? That sounds kind of funny, like slap. Okay, so this would be 19.6 minus 19.1. Anti-frivolous lawsuits. Yes, I agree. This is why I say, and I say this, one of my sisters is a lawyer, but she's like an immigration lawyer. I say the lawyers fucking ruin everything. Lawyers really do like any sort of common sense that we have. Lawyers find a way to like exploit it and get money. And then, you know, there are good things like class action lawsuits. Like, I agree that you need legal things to keep people in check, but most of the time, the only people making the money off those things are the lawyers. Like, you know, if you file like a $200 million lawsuit because like cereal like gave people cancer, guess what? The cancer patients get like 2 million. The lawyers get like 198. It's so dumb. Ooh, I like that. Oh, that's cool. Yeah, Jeff's got a little definition there for the slap lawsuit. Yeah, no. In this case, like, UCLA has the money, but it's bonkers, dude. Dude, what university is gonna pay $1 billion due to some like bullshit anti-Semitic whatever claim? That's absolute trash. I hope they don't settle at all. Like, just wait for the dude to leave. Or wait for the midterms to like put a muzzle on him, man. Dude, like, what? Like, I agree with some of the things Trump does. I agree with the what is it, the drop of the overhead from 50% max to 15, I'm cool with that. That's like a good idea. But just slapping a university with $1 billion as a fine just because you just don't like them, I mean, that's just that's psychotic. What's up, Decimal? Good to see you.
Nice.
Okay, so this ends up being that 0.0258. Do you understand what we did here, Drew? We took the difference between the... Do you understand? So we took the difference between the two here, Drew? And then we divided by the average of the two. I don't think Harvard is one. Harvard is still in negotiations. Yeah. So... Yeah, okay, cool. And then times by 100. Columbia University folded. They paid, I think, 200 mil or something is what they did. But to be honest, like, Columbia did, like, kind of mess up. Like, that was kind of ridiculous what they had during their protests. They let, like, a bunch of, like, non-university people take over their buildings. Yes, you get 100 and that's it. Yes, good. Good job. Yeah, Loki, yeah, you can chill and ask whatever, dude. There's a little bit of a queue, Loki. But if you want to submit a screenshot of something, that's great. Yeah, could I go over the Pythagorean theorem? I mean, yes, I could. It's just, it's kind of a... It's better to teach by doing, is what I say. You know, if you wanted me to, like, explain the Pythagorean theorem, there's a gazillion fucking YouTubers that have done that already. But if you have a question involving the Pythagorean theorem and you want me to, like, kind of go over how to use it and, like, why it's useful, that's unique. Yes, that's a great use of the stream, is what I say. So go find a question or something involving the Pythagorean theorem that you want to learn about and you want to, like, kind of do alongside. If you just want me to lecture here about the Pythagorean theorem, it's been done ad nauseum at this point. Not trying to, like, shame you or anything. I'm just saying, you know. Oh, Jesus. Are you trying to do that to me, Jeff? Don't do that.
That's dope.
Jeff with the fucking questions. Okay, Reki. Yes, I will help yours out. And then, Shantrix, I guess we'll look at yours with the Venn diagrams. Breaking news. Student finds another proof of the Pythagorean theorem for the... Oh, Jesus. What's that number, dude? That's way too high. And then, ooh, we do have a lot of screenshots on the help screenshots. Oh, nice. I like all these. Wow, a lot of you guys submitted a lot of stuff. Here, let me... Yeah, this is great. Well, Martinez, you submitted the same screenshot like 4 times. Here, let me just show them for the people that are watching. So, this is one screenshot we got up. And then we got Tatum Hiley. That's another cool one. I like the differentiable. That's pretty fun. And then Sibley... I think you submitted one screenshot as well. So let me just pull these all in real quick. Just to show you guys, I have your questions. We will go through them. Nice. Good thing to know the website's working. Okay, Reki, let's see. You kind of forgot existed? No, YouTube, yeah, YouTube's great. Yeah, I mean, that's where we're streaming, low-key, by the way. But yeah, go watch a video about it, and then go find a question about it that you don't know how to do, and then I'm more than happy to help you with it. So that, you know, it can make sense to you. Nice. 10 stream streak. Good job. Okay. State the period for each periodic function in degrees and in radians. Sketch the graph. Okay, so I'm not going to do all these, but... I'll do some of them. Okay. Anytime in general, you have, like, sine of... Oh, ooh, that's way too thick. There we go. Anytime in general, you have, like, sine of, like, let's say, like, something times x, right, for instance. This part, the number in front, and again, this could be x, or it could be, like, theta, like, whatever. It could be theta if you want as well. Theta, doesn't matter. Or I don't know, like, sometimes k. No, not k. Or t. T is one that comes up as well, a lot of times. this part right here, it's omega, which is, is that 2 pi over the period? I think this part right here is going to be 2 pi divided by the period. Let me think about that. The way I know it is that I know it's omega x, and then omega is equal to 2 pi 2 pi f, and then f is 1 over period. Okay, yeah, it is. Okay. Yeah. So whatever number is in front of here, that's equal to 2 pi over the period. So here, for instance, if you have sine of 4 theta, right? That means that 4 is equal to 2 pi over the period. This is for like question A. So, period is equal to pi over 2. Just, flips, change the... You guys call it the butterfly method? I think you guys call it the butterfly method. Yeah. Nice. And then that's probably already in radians. Yeah, that's already... This is in radians. If you ever want to convert to degrees... You just take whatever you have in radians and you multiply it by 180 over pi. Okay. And that'll get you your answer in like degrees. Cool. So if you wanted to do this, well, I already know pi over 2 is 90 degrees, but if you want to show like why it is, so for instance, for example, if you had pi over 2 times 180 over pi, these cancel, and you just get 90. Yes, 90 degrees. We like pi. Yeah, pi is 180. 180 degrees. Yeah, I should put the degrees thing. Okay. Cool. Yeah, so just take all these things. I mean, if you really want to do it, let me think how you would do this. You would do 2 pi over the argument. Yeah. So in this case, period. And period is like how often it takes for it to do a complete cycle. Is equal to 2 pi over whatever the green thing is. Whatever's in front of your variable. Whatever's in front of your independent variable. Yes. Yeah, that's another good way to do it, Drew. Yeah, you're totally right. It's one of the things you just get used to. You get used to, like, which one is 90 degrees, which one's like 180 and whatnot. Yeah. Cool. That's a pretty easy one. Well, let me fix my green screen. I got this new green screen on this port because I wanted to like hide my cables. Need to make sure it looks okay though. Okay, I think it looks better. Okay. Nice. Okay, yay. Good job, Reki. Let me see we got a lot of web screenshots coming in. Mohammed has a good one. Ooh, this is Euler's totient. Okay, I see. Some of y'all are like asking some really, really difficult things. This is what I get sometimes when I start streaming to TikTok. I get some absolute math whizzes that want me to solve things like this. Like, first of all, I have absolutely no clue what like Euler's totient function is. Does anyone in my chat know what Euler's totient function is? I'm curious. Let me see. Let me do some of the web submissions. So Sibley, is this number theory? Zumpal, is that what it is? Sum of factors. Okay. Let me try to do this one. I have a problem with this equation. 2x squared plus x equals 20. Ooh, that's a great one. See, Bestow, that's an excellent question. That's an excellent question. Yeah. Let me just do that one real quick. Just 'cause it'll make me feel happy. And then, Sibley, stay tuned. I'm going to do yours. But just because this one's easy. Oh, wait. 2 to the x plus x equals 20? Oh, wait. No, never mind. Uh-oh. No, I can't do that one easily. I thought you had x squared plus 2x. X squared plus x was equal to 20. All right, let me see this. What class is this for, Sib, by the way? What is this? This looks like vector calc, maybe. Euler's Totient function known as 32b. Is that vector calc, Sib? Is that multivariable calculus? Are you taking this over the summer as well, or are you just prepping? You were supposed to take it before my class. Well, thank God we didn't actually do any of this in my class. This is like path integrals and shit. Prepping for the fall, great. That is very smart. Sib's being a very smart person. They're prepping for the fall. Okay, let me see if I can do this like without looking at the answers. Okay, let C be an oriented piecewise linear path in the space joining the points. Lots of different points going on here. Cool. In the order of appearance, as in figure 1 on the next page. Well, I can't see figure 1, but it's okay. I assume it goes from 0 to 1, and then 1 to 2, and then 2 to 3, and then 3, whatever, you know, sequentially. What's up, Nick? Evaluate this on the contour. Okay. That dx, that dy, that dz. I believe you have to like find like a function for what connects these points, and this is kind of like parametric, no? Are these points coplanar? I guess one way to find out would be to see if the cross products between the two are all the same. I don't know that they are. I don't think they're coplanar. Yeah, if they're coplanar, then what is it like? V01 cross V02 should be the same thing as like, or I should say this. It should be the same thing. The magnitudes would be the same as like V01 cross with V03, right? What does coplanar mean? Good question. So coplanar means that the points could be described as in a and I hate using the word. You can describe the points in a plane. So an example of that, here we go. Let's say like coplanar points. Isn't this similar? Brother, you forgot to add the constant again? Uh-oh. Yeah, this is an example of like coplanar points. There we go. I like this. This is a great example of coplanar points. It's really for things in like 3 dimensions and more, but we usually just use 3 dimensions. So, yeah, coplanar would mean that you can draw like a 2-dimensional plane, and all the points would be in there. We are doing some Calc 3, yeah. You want to help out, Catnip? The way to determine if things are coplanar... What's up, Aleph? We're doing some vector calc. Is that if I were to draw vectors between these, let's say the vector between D to G and D to E, and if I were to cross product those vectors together, you get a normal vector, which would look like this, okay? And that normal vector should be the same direction. The magnitude doesn't need to be the same as if I were to do, let's say, for instance, like FG with FE. Here, let me use like different colors here. Let's do this. Yeah. Yeah. New follow. We love the follow. Maybe I should stream more on Fridays, dude. But yeah, this is a unique product, a unique property of cross products. Is that the cross product between 2 vectors gets you the vector like normal to those 2 vectors, which is in a plane. If you have vectors, which are just arrows pointing around in the plane between points, then you should get the same normal vector for any series of points there. Yeah, they're not perpendicular. I guess they are perpendicular technically, but I mean these aren't like perfectly perpendicular, right? You see how like there's like kind of an angle. It's if you have multiple points in the plane and you make vectors between those points, then the cross product of those will always give you a vector that's normal to that plane. And so the way you can determine if points are coplanar is that the cross product between the vectors should give you the same normal vector. Vectors don't care about where they start. It's really just like a direction thing. So this normal vector should apply anywhere. Yeah. Thanks, Panson. Oh, you're just leaving a follow? Thank you. Appreciate that, Panson. Yeah, we got 3 follows today. That's sick. Actually, 4? 4 follows today. And a donation. Doing pretty well today. What's up, Anish? Oh, Physics 1C is going well so far? Good job. Is Nathan teaching it, Anish? Or not Nathan, sorry, Frank. Is Frank Sung teaching it, Frank? Who is teaching 1C for the summer, actually? Or I think Nathan is, actually. I think Nathan's teaching 1C. Yeah, Professor Tung. Yeah. So there's Frank Sung, and then there's Nathan Tung. Yeah, there's 2 of them. Yeah. Okay, that's cool. Yeah, I talked a lot with Nathan, because he's been teaching online for a while, because he not only lectures at UCLA, he lectures at like Cal State Pomona and Cal Poly, I think. So yeah, but he does a lot with UCLA. He should be pretty good. He's a G. The mixed product is the coplanarity criterion. Oh, I didn't know about that. That's cool. Okay, but let's try to do this. Okay. Sorry, we went on a little bit of a tangent, but I love tangents. I love sine and cosine too. But yeah, that was just that's a good question. So you asked about like what does coplanar mean? I don't think these points are coplanar. They seem to be like all over the place. Bump them. Yeah, did you like my joke there? Okay. Let's see. So we need to do a contour integral. Wait, C is the path, or is this a path integral? Well, here, I can actually check the solutions. Okay. They are just giving you a bunch of points. Correct. Okay. Write F is equal to F1, F2, F3 for the vector field to be integrated. Oh. Then F satisfies the cross-partial condition. Yo, where the hell did this come from, dude? What? Excuse me? This is a pretty trash solution, dude. What? This is like someone asking, how do I drive? And then the person says, okay, so you want to like take a chicane at like 45 miles an hour with a, you know, like what? Teach someone how to like first put their blinkers on, man. What the hell is this all of a sudden? Yeah, it's okay. Math people get like pretty ridiculous with just like throwing you to the wolves. I assume that this is the vector field they talk about. Yeah. Yeah, okay. Okay. They could be a little bit better about this. So what they're stating is this is the same thing as like the integral, the contour integral of some vector field. And I want to say maybe this is like dr. Is it vector field dr? I think this is kind of how this works, because in this case we're saying that f, which is a vector, is equal to 2x z cubed comma z cubed comma, and then this 3z squared x squared plus y minus e to the minus z, like this. What do channel points do? You can like do stuff on the stream. You can like you can like trigger Master Chief to come up if you want or something. Where's Master Chief? Here you go. No, you're okay, Ethan. Good to see you. But you can also buy bond coins and stuff, which is our currency in the server for earning gift cards. Fun stuff. Okay. Does this make sense so far, Sib? So I think this is what's happening And if you were to do f.dr and then dr here, what's up, Thuma? You should definitely, yeah, limits are a great way to start learning things. I mean, you don't need limits to know how derivatives work, but it is going to be the first topic in calculus for sure.
There you go, someone got baby voice. Yes, now my voice sounds like a baby. Okay, so then this would be dx, comma, dy, comma, dz. Isn't that work done from yeah. So I think that's how this works. Oh, you have a screenshot for me? Yeah, okay, cool.
Yeah, I think that is the way to do it, Jeff. Yeah, so let's see like what this path looks like, right? So I think what you're doing is you're evaluating this integral, but then you're like parameterizing the limits such that you travel from like here to here, right? So in this case, when you go from 100 to 101, wait, where's 101? 101. Is this what this doesn't look like 101? Sorry, excuse me. What? 01. Yeah, that's what this is. Okay. This is like 101. Is the answer e minus 1, or have I messed up? Is the answer really just e to the minus 1? Are you saying this whole thing? Might be. But yeah, so here's what happens is as you go from 100 to 101, right? And you're integrating this function, right? Your dy is 0, right? Do you notice how there is no change in y as you go from this point to this point? There is also no change in x. There's just a change in z. And then more importantly, so I believe for the first part, you only look at your change in z. And then you also know that y is equal to 0 the whole time while you're doing that integral. You got e minus 1. Oh, maybe. We'll see. So if y is equal to 0, right, that means you get to like just remove this. And then I think this is just, I think literally you just do this from 0 to 1. Right? I want to say you do. And then also, like, x is a constant, right? X doesn't change as we're going from this point to this point. That's my gut intuition for how to do this. Whenever I think path integrals. Luckily, these are nice paths. They're right angle paths, right? We're going from like here. So like, you're not changing dx and dy like all at once. You're only usually changing like one thing. But let's see. I want to try to explain the solutions for you, Sib. Okay, so they talk about like f is a vector field. Okay. Definition of a vector field is that, right, that amongst this path you're going around, there's a bunch of like arrows, right, that are describing this function f, okay? And depending what your x, y, and z coordinates are, you end up having that field pointing in different directions. So for instance, at 0, 1, well, here, let's say for instance at 100, right? It is like an yeah, this is a really goofy ass field though, right? So for instance, at 100, that would mean x equals 1, y equals 0, z equals 0. Your field would just be equal to 0, 0, and then -1, because e to the negative z is e to the negative 0 is just 1. So at 100, you would have a field that has the vector 0, 0, 1. Does that make sense? Like this garbage here is just describing what the value of the vector is at different x, y, and z positions, and like how it's pointing. Also, right, there's a magnitude to it. The magnitude would be once you have your vector doing the, A bit. Yeah, no, I agree. And again, honestly, I'm relearning it with you. Because it's been a while since I've taken vector calc. I do need water, thank you. Good to see you, Sam. Oh, it's dripping everywhere. It makes you feel better? Yeah. Honestly, I think people teach shit better if you learn alongside them. If you were to give this to like a math person and they were like, hey, explain this, they would just be like, oh, well, it's fairly obvious. It's just blank, 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 blank. But, which is kind of how these solutions are working, like, honestly, right? These solutions off the bat, when they just start saying, like, write F as this for a vector field to be integrated. First of all, dog, you never said this was the vector field. You just, like, just dumped this shit on me. Like, what? So, we're explaining that. Okay, cool. So, what they're showing is, okay, cross partial condition. They're showing that it's a conservative force. Oh, man. Oh, I think I see what's happening here. They're creating a potential out of a field. Do you remember? We did do this. What's up, Roman? We did this a little bit. I hinted at this in physics. Do you remember, for instance, like the integral of E dot dl was equal to, oh, I don't know. It was like the potential. Right? Yeah. So this, for instance, is a vector field. And then as you travel along that field, there's an associated potential with it. And so that's what they're talking about here. They're saying, okay, if I have a field F, and if I think there's a rule here, in order for there to be a potential, you have to define the vector field as being conservative, which I think by being conservative means that the path you take doesn't matter. Let me, you know, okay. Let me ask about this. I'm going to use good old ChatGPT to try to teach me a little bit about this. Okay, so, for a vector field to be conservative, does this mean that the exact path between 2 points doesn't matter? Conservative means that a closed path would yield 0. I agree with that. Yeah, so if you're starting and your finishing point are the same, then nothing happened. I think that's what, yeah, conservative means. Here we go. Yeah, in a conservative vector field, the line integral between 2 points depends only on the endpoints, not on the path. Okay, great. So, yeah, I think that's what we're getting at. I mean, that's what I thought. I'm just double checking myself. But, right, this was usually how we calculated electric potential due to an electric field. Right? We did some, like, E dot dl, and then this was, like, the potential. And so if we did, like, from A to B, this is the potential between, or no, I don't know. I think it's B minus A, but whatever. Maybe it's A minus B. Minus signs, who cares? Kind of like a ball dropping. Yeah, exactly. Yeah, okay, cool. And so what we say is that, right, this is what Jeff was saying. Every closed loop integral is 0. So if you start at a position in the vector field and you come back to the same position, there should be no change in the potential. Yeah. And kind of with the ball dropping, right? If the ball is here, it drops, and then I pick it back up, and it's at the same position, the change in the potential energy there is 0. There was no change. Okay, cool. So, ways to check whether it's conservative. So here they say if curl F is equal to 0. This is cool. I'm going to show you how this works. This makes so much sense now with their solution. Again, dude, fuck these fuckbags, dude. They don't explain any of this. I hate math solutions sometimes. Just they're assuming so much. Okay, so here's what you want to say. Like, this is cool. This is a good dive sib. I haven't done this in a while. F is conservative if grad cross F is equal to 0. Okay, this is called the curl. Now, do we remember how to take the curl of something? Remember that grad is like ddx, comma. I say grad is, or nabla, I guess, sorry, is just like super derivative. It's a derivative in all directions. Check out my Perplexity AI if you haven't. It's free. Many say better and has different modes like research. Oh, check out Perplexity. I haven't. Okay, well, that's a cool idea. I'll look at it. Perplexity. Just for next time. We're gonna leave this in my thing. Oh, is it Cloud? Oh no, that's just them advertising. Wow, sneaky fuckers. Wow. Yeah, 1 second. ChatGPT is just like the first one I started with, and I do really like it. But okay, cool. I'll check this out later. Okay, so yeah. So if you want to do curl cross F, you have to kind of do this. So this is how you do a cross product. So if you have like A cross B, that's like X hat, Y hat, Z hat, and then it's like AX, or we say like A1, or whatever. I'm going to do it in 3D. AY, AZ, and then it's BX, BY, BZ. Yeah, I'm a creature of habit. I might switch over to Gemini, honestly. At this point, if ChatGPT doesn't get their shit together, I really don't like what they did with 5. Yeah, so this is you're good, Sid. Yeah, so this is, for instance, this is what a cross product is. So if you want to do nabla cross F, okay, that's equal to the same thing. So this is going to be X hat, Y hat, Z hat, and now this thing are all the derivatives. So this is partial X, partial Y, partial Z, and then this is going to be FX, FY, FZ, okay? And then you need to remember how to do determinants of 3x3s. So the trick is you always do this, right? And then now this is the 2x2 you look at. And so this is the diagonal thing. You do like this minus this. So this is going to be dfz dy, because that's this acting on this, minus this and this together. So that's dfy dz. And then that needs to be in the x hat. This is a matrix. Yes. Drew, this is a matrix. This is a 3x3 matrix. It's a matrix with like operators in it, but yeah, it's totally a matrix. And then this is all for the x hat direction. Oh, Perplexity is great for computer science. Nice. And then what happens is you take this and you move it over to the right. And then you do this minus this. So, and then technically there's another minus here. These are just like rules you have to know. So then this becomes dfz dx minus dfx dz. And then that's in the y hat direction. Yes. I don't know if I did 3x3 determinants, but they're related. Now talk about 5-dimensional tensors. No, I don't want to.
You gotta get in the hospital now.
I'm not going to the hospital, dude.
Yeah, I just said just shut up and let me enjoy this pain.
Yeah, don't worry, Drew, about what the symbols are now. You will eventually learn what they mean, but the process is the same. Okay, so then I have dfy dx minus dfx dy, and that's going to be in the z hat direction. And then here's the cool thing, okay? If grad cross f, which is curl, has to be equal to 0, then that means this whole thing has to equal to 0, right? So that means that this must equal 0, this must equal 0, this must equal 0. Or other ways to say that is that dfz dy has to equal dfy dz. What's up, Abhisha. That's a cool name. This has to equal to this. And then this has to equal to this. Okay. That's how you prove something is conservative. You show dfy, so you show the derivative of the z component of f with respect to y is equal to the derivative of the y component of f with respect to z. It all comes from this. And that's exactly what they're saying here. So here they're saying df1 dy. This is the same thing as saying dfx, really. Like 1, 2, 3 are just different indices we use sometimes to describe the different dimensions. Yeah. So dfx dy equals dfy dx. That's what we have right here, right? It's the same thing. So, okay. So they go ahead and just show that they all equal each other, right? Okay. So, for instance, dfx dy is saying, look at the x component of my vector field, which is this. Take the derivative with respect to y. This doesn't have any y's in it. So the derivative of this was 0 with respect to y. And then the derivative of the y component of your vector field with respect to x, again, there's no x's in there, also 0. So you get that they equal each other. They both equal 0. So, yeah. That's where it comes from. Okay. Scammed. What'd you get scammed at, Atari? Cool. Okay. So, if you assume it's conservative, and then you can prove it by performing all these things, which is what they do right here. Dude, what is this track? This track sucks, dude. Excuse me. Shout out, whatever, dude. Chill. Then, we know F is is conservative. This is so cool. This is, again, more physics coming up. It's really math, but I'm going to show you where this comes from. So, do we remember as well that if this is the definition, right, for electric field and potential, that the gradient of potential is equal to the vector field? In simple words, we did this as like the change in potential over the distance was equal to the electric field. Yeah. So this is like the big boy like calculus, vector calculus version of this. Because this is only in one dimension. But yeah, so electric field is the what's that called? Is that called? It's the gradient. It's the gradient of potential. Okay. So a match channel or a math channel, yeah. So this tells me, because again, remember gradient is all three of the derivatives together, all three dimensions, right? Where's gradient? Here's gradient, right? Okay, so gradient f is equal to, gradient, they're saying little f is equal to big F, where this is the potential. Okay, so that means df dx is equal to fx, df dy is equal to fy, and then d little f dz is equal to fz. Because this ends up having like three different components. And I know that fx, yeah, electric potential, correct. Yeah, not electrical potential energy, electric potential. We're now doing things in math land where nothing is technically electric. It's just potential. They're calling it like, it's just fields and potentials. In reality, the reason we do this is because if you understand the framework of how this works in math, you can apply this to any sort of field or potential in different parts of physics, like gravity fields and, I don't know, like nuclear fields or whatever. Magnetic fields. Yeah. Like there is a magnetic potential as well, which you'll learn maybe in 1C. Math transcends reality. It does. Okay. So if this is true, right, that means df dx is equal to that. So I can move this over to this side. So then I say that partial little f is equal to fx dx. And I think I can just integrate. I think I can. Well, I think there's going to be a constant. So this tells me that the x component of my potential, I think, is equal to the x component of my field integrated with respect to dx. So that's 2x z cubed dx. And if you integrate that, that gets you fx is equal to x squared z cubed. And then I think it's plus c. Maybe the plus c goes away. Let's see. So, yeah. Oh, I see. Yeah, okay, never mind. The plus c is that there's another part of the function that doesn't depend on x and only depends on y and z. Okay, so yeah. So they took this. We integrated both sides. We get this. Or actually, sorry, no. This is what we did. So this is dfx, and then we integrated both sides, and then you get this. But this c is just something, we say it's a function g that depends on y and z. What's up, Lucky Strikers? That's a cool one. Sin x over x? Yeah, okay. Yeah. So, cool. So, you get f is equal to x squared z squared. Oh, actually, interesting. This is not in the z component because potential doesn't have a direction, right? Potential f is just some f of x, y. What's up, Master Chief? It's just some function of f, some function of x, y, and z, but it doesn't have a direction. So this is like a puzzle. So what you end up finding is that, like, okay, f needs to have x squared plus z cubed, x squared z cubed plus some component of yz, and then from this part of the puzzle, so if we look at the y component and we integrate that with respect to y, oh, this is so cool. So this is like the first step of the puzzle. So like first, this is kind of like playing, like you're like eliminating things as you go down. So you know that the function is x squared z cubed plus some function of y or z, and then you know the derivative of f with respect to y is equal to z cubed. Beginner to start studying cryptography. There's probably some cool YouTube videos you can watch on it. Cryptography, I believe, is all math algorithms, so learning like algorithm stuff is probably useful. Although all that stuff's gonna get really weird with like quantum, like computing and quantum cryptography. Okay, so df dy is z cubed. That comes from this, right? So I know the derivative of the potential with respect to y has to be equal to z cubed. And now, if I look here, right, the only thing that depends on y is this last part, g, y, z, g of y and z. This doesn't depend on y, right? So that tells me that dg dy must be equal to z cubed. Okay? So now you get an expression for g, because if you move this over, now you have dg is equal to z squared. Here, actually, I think I can do this. I can fly now. I think I can fly. This is the beautiful thing about, like, you use the solutions as much as you need to, and then like try to do it yourself. That's the actual like work you need to do to be able to have this sink in. Okay, I know f is x squared z cubed plus g of yz. But okay, by this we know that df dy, where little f is the potential, has to be equal to z cubed. So dg dy is equal to z cubed, because this does not depend on y. There's no y's in it. So I know this part. This is the only part that can like spit out something with y's that like get me a non-zero thing for the derivative. That tells me that g is going to be equal to y. So here you can integrate both sides. So you get dg is equal to z cubed dy, integrate, and you get that g is equal to z cubed y plus h of z. Because that's the missing thing. We haven't taken something with we haven't taken derivatives with respect to z yet. And then for my final trick, which is this is where things are going to get really ugly. I know that df dz is equal to this fucking mess. Is equal to this. Okay. Do I want to integrate this with respect to z? I guess I have to. It's not the worst, actually. Yeah, okay, because he's just here. Okay. So that means, so df is equal to this dz. And if I integrate that, I think I get, so that's z cubed over 3. So that's just z cubed x squared plus y. Integral of e to the negative z is negative e to the negative z, so that's plus e to the negative z. Okay, cool. But wait. But now I have things with x and y in it. Uh-oh. Oh, okay. First of all, here. Okay, so far, one sec. When we got to here, now I've built my f as equaling to x squared z cubed plus z cubed y plus h of z. Okay. Okay. All right, this last part, a little tricky. I think I literally just say this. Okay. Okay, is f equal to x squared z cubed plus z cubed y plus z cubed x squared plus y plus... Oh! Ooh! You want to know what's really cool here, Sib? Watch this. Look at this. Z cubed x squared z cubed y. It's already there. Oh, this is beautiful. This is really cool. So look. Okay. So that tells me f is equal to this, right? But this is already here, right? You see how this is z cubed x squared plus z cubed y? Oh, one sec. I gotta validate my TikTok. They get mad at me if we stream for too long. Z cubed y plus e to the negative z. This is already here. So that tells me that h of z is just equal to e to the negative z. Oh, this is wicked, dude. This is so wicked. Okay, so f equals z cubed x squared plus z cubed y plus e to the negative z. And that's our potential. Yeah, isn't it cool? I don't know. I guarantee I learned this probably like 15 years ago when I took vector calc, but it's like coming back to me. So that's why it's like rad for me. I think it's cool. It's cool when math like just works out. Yeah. Yeah. Cool. Oh. So wait. Someone in my chat earlier just said the answer was E minus 1. And the answer is E minus 1. Wow. Yeah. X squared plus Y Z cubed plus E minus C. Okay, there's plus C. And then here we go for conservative vector fields. This is the fucking coolest part of this whole thing, Sid. Is that you don't have to do the integral from 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. You were so right, Joe. You just have to do from here to here. Because you don't care about the path in between. Right? Yes. Oh, man, this is so cool. So, yeah. So, the integral of your field dot dr from... It is a very cool problem, Joe. Yeah, isn't it fucking cool, man? Sid, where'd you get this question from? I know this is like a basic, probably like vector calculus question, but I think it's really fun. So 1, 0, 0 to 0, 0 minus 1. It's midterm 2. Okay, that's cool. 1, 0, 0 to 0, 0 minus 1. Okay. That's just going to be f at P6 minus f at P0. So at P6, and also this is plus C, right? But the plus C will go away when I subtract the 2 points. So really, I don't really care about this. Someone's going to get mad at me for forgetting that. Okay. So at 0, 0 minus 1, this is 0. This is 0. So you just get e to the 1. Minus 1, 0, 0. So again, 0, 0, minus 1. So that was e to the minus 1. E to the 1. E to the 1. So it's just, yeah, it's e minus 1. Wow. Super cool. That was sick. It was like beauty of just like math. Jeff, are you happy we're doing math again, dude? You happy we're doing math, Jeff? Jeff is so happy we're doing math. Sick. That's really cool. This physics crap was getting to me. Yes, if you're watching us from TikTok, and you want, I'm working on getting my other chat to broadcast on TikTok, but we're also live on YouTube and Twitch, and you can see the other chats that way. I have them all integrated on YouTube and Twitch. I'm trying to get TikTok to port over. They're really strict about streaming and like giving out keys. Thank you so much, Dr. G. I'm going to rewatch this and study this so much. I'm glad I took your class before this because it gives me more intuition, or none of this would have made sense. It feels like physics. It really is physics. It is. Pitch me an idea for a startup. You're watching one, dude. Yes, you're right, Drew. The plus C is a constant. It's a constant of integration. Because what it says is if you integrate like a curve, it's equal to like the derivative of the end minus the derivative at the beginning, but then there can be like an offset. There can be a vertical offset. Yeah. Let me like just show it real quick. It's probably in like visual. Yeah. Yeah. It has to do with how integrals work. I wish there was someone should make a nice graphic for this. Yeah, Shantrix, I'll do yours next. Here, I guess this is kind of like a good example of it. So, for instance, these are all functions where, like, if you took the derivative of it, you would get the same value. Because this last term goes away. Because it doesn't depend on x. So, all of these functions are technically the antiderivative of, what is that going to be? X squared plus x. Yeah, these are all the antiderivatives of x squared plus x. But it's x squared plus x plus c, because you could have the function be like vertically offset up or down. I'll explain this more in depth at another point. It is cool. Let me do, yeah, Shantrix, you've been waiting a while. Let me do Shantrix's. And then we'll get to the other queue of ones we got. I guess Friday is pretty popular for the streams. Yeah. Not this. Sorry. Alright, just to show, we'll do... If people are here, I will do your questions. They're in the queue. Can I please copy this? Have I done this one, Shantrix, by the way? I wonder if I have. Okay, each student in a math club is either the junior section or the senior section. No student is in both sections. Of the junior students, 60% are left-handed and 40% are right-handed. Of the senior students, 10% are left-handed, 90% are right-handed. No student in the math club is both left-handed and right-handed. Well, I don't think anybody can be left-handed and right-handed. Right? The total number of left-handed students is equal to the total number of right-handed. No, don't tell me that. No. Really? Don't tell me there's a mix. but these add up to 100%. Right? If we allowed ambidextrous, wouldn't we have more than 100%? Is this one of these math contest questions? I hate these. Yes. So, I used to be in the same boat with you, Drew. I used to abhor these questions because they're like difficult for no good reason. But as Shantrix says, like, this is like Shantrix's signature. He sends me these math challenge questions. I have started to appreciate them, and I actually do like them now, because really what they're doing is just showing you tricks in math. And if you do enough of them, you start hating them less, because you start seeing patterns. Yeah. You could be an amputee. Yeah, what about the amputee with no hands? Look, Mom, no hands. So yeah, let's just go along with this. Okay. Determine the percentage of math club students that are in the junior section. Are you planning on teaching at UCLA next year? Well, I don't know. They just got slapped with $1 billion lawsuit by Daddy Trump. No. So I don't know. I would love to teach next year at UCLA. But I think UCLA is going through some problems. Or really the whole country is. But yeah, we'll see. I'm gonna talk to the department next week. Yeah. Okay. I'm tempted to draw Venn diagrams. I just like Venn diagrams. Right? Okay. Junior students. Senior students. And I'm just going to assume like 100 juniors, 100 seniors. Or whatever. Okay. So, 0.6J is left-handed. 0.4J is right. Yeah, you're right. I'm not going to, Jeff. Yeah. You right, Jeff. Okay. The seniors, dude. What happened to all the? Did they just like get rid of all the seniors with they were left-handed, dude? Dude, what? 0.1 of the seniors. I don't think any amputees or ambidextrous people are counted. Yeah. They're still people, but not in this question. Okay, these are right-handed. Okay, cool. No student in the math club is both left-handed and right-handed. I don't think any student can be left-handed or right-handed. I'm confused at why they gave us this statement. Right? It seems like what do you call it? Extra information or whatnot. Okay. The total number of left-handed students is equal to the total number of right-handed students. Oh, sorry. All these people are in the math club. Okay, now I see it. Okay. So, the total number of left-handed students. So, that's 0.6J plus 0.1S is equal to the total number of right-handed students. Oh, okay. So, that's equal to 0.4J plus 0.9S. The total number... Oh, okay. Well, wait a minute. Oh, determine the percentage of math... Okay. Determine the percentage of math club members that are in the junior section. Very cool. Thank you, Jeff. Yeah, I was like, wait, I only have one equation and 2 unknowns. Okay. This actually isn't that bad. I thought this was going to be worse. Okay. So we're saying from this information, we need J over J plus S. You could also solve for J in terms of S or the other way around. Yeah. I agree. So what Shantrix is saying is that if I rearrange this for S, okay, then I get that 0.8S is equal to 0.2J, right? So, I don't know, multiply by 5/4. So, S is equal to... Sorry, my... yeah, okay. So, 0.25. Should have known that. 0.25J. J equals 4S. I agree with that too. Yep. So then I can plug this into here. 80%. Yeah. So then J over 1.25J. So yeah. That's 1 over 5/4 equal to 4/5. 80%. Oh, that's actually not too bad. Nice. That's a cool question. I like that one. That one didn't hurt. I thought that one was gonna hurt more.
Well done.
Yeah, this wasn't a bad question. I don't really. Well, oh, this is the no ambidextrous, I guess. Yeah. Eliminated. Yeah, I agree. Okay, cool. Well, that's a cool question. That didn't hurt too much. If equity shows up, I'll help out equity. Otherwise, let's see. We have a convergence question. Differentiable on the infinite timeline. Euler's totient. I don't know what Euler's totient is. I think I can do this one. Bro, what I look like? What did I look at? This is not math. It's kind of math. Yeah, it's just a little bit of. It's just math in different forms. Is this just a root test? Is this a root test? I want to say this is a root test. Let's just try to do this one. That is ugly. I think it diverges. Okay. I think it's just a root test though. Isn't it? Isn't it just a root test? Oh, it has the floor function in it? Wait, sorry, what? Wait, what? This isn't just like some like brackets. Gold, how did you get your tutoring job at UCLA? I wasn't a tutor at UCLA. I was a professor, but lecturer per se. What do you use to get all those questions? People submit them. So there's a link down there at the bottom, actualdiscord.com/submit. If you send a screenshot, so here I'll show you. It's pretty easy. You can put your name, you can upload a screenshot, and then we'll get it here on the stream. We'll go through it. But yeah, to answer your question, Taco, how did I get the job? There was an opening, and they sent an email out asking for people, and I applied, and I got it. So that's what happens. Was I at UCLA for just a year? Yeah. Well, 2 quarters, actually. We'll see. I might be there later. It's just, there's a lot of weird stuff going on right now. Oh, I appreciate Sib. That's really nice of Sib. So you're not going back. I'm just like not hired. Like they don't have money to pay me. So I'm not gonna go work for free. There's, if you read the news, Taco Cat, UCLA is going through a lot of weird stuff right now. I teach physics. So I teach undergraduate physics. So mechanics, E&M. We did a little bit of fluids, I guess. Yeah. Thermo. You don't really care about the news? I mean, that's kind of a valid point, but... Alright. Jeff seems to think this is going to be weird because it's a floor function. Wait a minute. Isn't this thing here just gonna oscillate? Can I just say by alternating series test that this is yeah. Wait. Can I just say alternating series test? Well, n starts as 1, but then n just keeps going up. Jeff says I can't use the alternating series test. It just needs to alternate and it needs to go down. Isn't that right? Check the first couple. Fine. Okay. Yeah, let's write out a couple terms. What's up, Fedekai? Okay, so -1 to the 1 over 1, so that's just 1. And then you have -1 square root of 2 is 1.4, and if you floor that, that's 1. So that's equal to -1/2. Oh, square root of 3 is like, oh, I see. It's not alternating.
You done messed up, Aaron!
Oh, that's sad, dude. It doesn't alternate. Oh, no. What type of math is this? This is pain. This is pain math. I don't know. Wait, well... Let me see. What do I got? We got a root test, maybe? Give me the root test. We love Paul. Tensors? Ugh. I can attempt it, but I don't really know. I don't really deal much with tensors. Fedekai, yeah. Okay. It's okay, Taco, if you don't understand what's going on. This is kind of advanced calculus. Okay. The nth root of a to the n, if L is less than 1, it's absolutely convergent. If L is greater than 1, it's divergent. It isn't. Can I do? I feel like I can do the root test on this, right? Oh, it's the square root of n though, isn't it? Fuck. What does this solve in the real world? Not much. You are right. This is one of these things where like students start asking me like, why the fuck would I ever use this? You're never gonna use this. This is ridiculous. This is well, but in the same way, right? You know, I went to the gym today. I benched what did I get up to? 245. When in the real world am I gonna have to like lift 245 pounds off my chest? Like never. What? I hope not. I mean, that would be like a really bad situation. So, but I didn't stop doing it just because I'll never do it again or never use it like in the real world. But you're still building like strength in doing the thing. So in the same way here, when are you going to use this math in the real world? 99.9% of people will never use this in the real world. But figuring out how to solve it develops skills that allow you to solve other things. So think of it like it's like going to the gym. This is like the math gym. And we're trying to like build up our math muscles. Because you do use math for other things. Gold, how do you find time to work out during your tutoring, usually lecturing and office hours? Not much sleep. Yeah, I don't have a lot of time, to be honest. The hope is that one of those three things, well, I mean, going to the gym isn't going to really like work out for like income, but one of those things that I do eventually supports myself so I don't have to do all the other things. Like, I enjoy lecturing, yes, but it's not that much money, you know. But so that's why I also have to tutor. But also that doesn't pay enough much. That doesn't pay enough money on its own. And then this is like my gift to the world, the like nonprofit stuff. But if this took off and like grant people started taking me seriously, which they will eventually, it's a time thing. Then I wouldn't have to do any of the other things either, because then this would just be paid for, which would be great. So, yes. I want to work out, but homework and school are just too much for me. Yeah. Definitely in high school, I would say it seems like you don't have a lot of time. As you get older, like especially if you go through college and then after college, you don't have homework anymore. So that gives you more time to do stuff. I did not call you yet, Nick. No. Okay, I'm going to ChatGPT this just because I don't know how to do this. Yes, we are on our... We're working towards our 5th year with streaming. Well, let me see. Actually, I can see when we started the YouTube channel. One sec. Where is it? Yeah, April 15th, 2021. So, what's that? 4 years and 4 months? We're working on 5. Ooh, I've uploaded 1,000 videos. That's pretty cool. 1.2 million views. Still haven't seen a dime from YouTube though yet. All right, let's see what ChatGPT says about this one. Maybe I'll send it at Perplexity too. You guys seem to like Perplexity. PhD's even worse though. So much real work. Yeah, I mean, I had a lot of time during my PhD actually. I had a lot of time during my PhD. I went to Thailand for a month. I just like told my advisor I was gonna like work abroad or something, and he was super chill. He's like, yeah, okay. So I just went to Thailand for a month. The PhD, the amount of work you need to do is dependent on how fast you want to graduate. Like, how much time are you willing to live at poverty wages? If you're cool with making 35 grand a year for a couple years, you can like lengthen it out. What's up, Motion? Next time you travel IRL, stream please. So ChatGPT is failing on this. It's having a rough time. I love how they put this little thing in here. Get a quick answer, because they don't want me to like keep sending it at their servers. Yes, Motion. Yeah. We just started streaming to TikTok again. We've been streaming the whole time. If you follow us on like YouTube or Twitch, I've been on like pretty non-stop for the last, again, 5 years almost. But yeah, TikTok was a new thing we were trying. So what happened, Motion, is I figured out how to improve my bandwidth by like installing massive antennas in my apartment complex. So now I have enough bandwidth to stream to TikTok, Twitch, YouTube, Discord all at once. Yeah. Okay, here we go. On the block, k squared. N is between k squared and k plus 1 squared. The sign is constant. Show a sub k is decreasing. Yeah, I mean, I guess so. It's 1 over n. Yeah, look, alternating series test. That's what I wanted. That's cool, and they do the error analysis by looking at the k plus 1 term. Okay, Jeff. So what they do here is man, this is weird. I think I understand what they're saying. But why is it k plus 1 squared minus 1? It stays between two perfect squares. It stays the same sign. Oh. Okay. Got you. Okay. So, yeah, answer is conditionally convergent. Aw, Motion. Thanks for the heart. Or the rose. You sent me a rose, Motion? Is that what you sent me? You sent me a rose. When I'm teaching, I don't have the guts to even show that I don't know the answer to a problem while you were literally showing us ChatGPT. Yeah, no, I mean, because we're all human, is what I like to say. Also, I tutor so many different courses. Like, anything from, like, stats, chem, physics, all the maths. I don't know everything. But I like to at least show the viewers that even if you don't know something, there's a way to figure it out. And AI is pretty fucking good. It's great. If you're using it to copy paste your work and get your homework done, no, it's bad. But yeah, I like to, yeah, I'm totally okay with admitting to my viewers that I don't know everything. Especially because, you know, some people give me just ridiculously difficult questions to go through. And if I know I can do them, I'll do them. If I don't, it's just showing that, you know, someone just tried to stump me. And I see the solution. It's okay, but it's excessive. If I was having to use ChatGPT to answer everything, right, then that would be bad. Yeah. Yeah. Because at that point, you're like, well, what do you actually know? I'm perfectly comfortable with admitting that, like, there are certain highly advanced things that I don't know. But that there are ways to figure it out. Yeah. Cool. All right. Let me see. Are any of these other... I get... These people sometimes just give me, like, stumpers. Like, do we think we can do this one? I feel like I know what the limit of sine of x over x is. I think isn't this a squeeze theorem problem? And also, oh man, as you know, as n approaches infinity, we don't really care about the plus p, right? The plus p is non-consequential. Yeah. Yeah, I mean, here, I think there's some value in showing how the squeeze theorem works, and maybe we can apply that to this question. No, don't need this. Yeah, there we go. So, by the squeeze theorem, you know that sine of x is always greater than or equal to -1. It's always less than or equal to +1, right? So, if you were to divide everything by x here, okay, and then take the limit as x approaches infinity, -1 over infinity is 0. Don't plug in infinity here. And then 1 over x is 0. So if something is greater than or equal to 0, but also less than or equal to 0, then this also has to equal to 0. Oh, thank you, Roman. Wow, we got a donation. Dude, I think you're my first YouTube donation. Thank you, Roman. That's super cool. I'll have to see, like, how that works. We just got YouTube partner, actually, a couple weeks ago. We hit the threshold for, I guess, allowing super chats is what it is, which I think is what you just did. I think you did a super chat, which is cool. I still need another, like, 500 watch hours before they'll let me get ad revenue on all of my videos. So we're still working towards that, but we hit the first stage of YouTube partner. I appreciate that. Thank you. Thank you, Roman. Dude, is that my first European donation? I mean, Sensation has donated to the chat in Twitch before, but you're my first European YouTube donation, and like my first donation on YouTube ever. Wow, you know what? You're gonna go on my Instagram story today. I mean, like, today I received my first donation on YouTube. €1. Yeah, he uses pounds sterling, yeah, but it converts to US instantly. The true European, not euros, the true European currency, yeah. Okay, so the limit as x approaches infinity of sine of x over x is equal to 0. Cool. So wait, how does that apply to here? Because I see, like, n approaches infinity of this. Do I have to integrate sine of x over x? Can I integrate sine of x over x? Is this an integration by parts question? Because, I guess this could oscillate, right? But they don't both oscillate. Fuck. This is my first Armenian donation. Yes. Thank you. Yes, I know Armenians always have the IAN or YAN at the end. That's why System of a Down, my favorite band, are all Malakian, Tankian, Shavo. Yeah, what his name is, yeah. That integral is bounded by negative log n plus p plus or minus log n plus b minus log n. Just integrate -1 over x and plus 1 over x. Oh, wait. Are you saying, like, do this? Like, instead of, wait. Wait. Jeff, are you saying this? Negative 1 over x is less than or equal to sine of x. Oh, that's really cool, actually. Oh, I've never done the squeeze theorem with integrals. Ooh, we're doing something new. Squeeze the integral.
That's dope.
Yeah, okay, that's fucking cool. Okay, so, yeah, we're going to integrate this. We're going to integrate this. Dx, dx, dx. And we're going to do it from n to n plus p. N to n plus p. N to n plus p. Okay. So, yes, this is integral of 1 over x dx is log of x. So that's negative log of n plus p over n. is less than or equal to. That's really cool. I didn't think you could use the squeeze theorem with integrals. That's kind of cool. Log does mean ln. I'm being Wolfram, dude. Don't you have to bound the integrand? Yes. So that's why I bounded it here, and then when I bounded it, I got this. Here, I'll put ln so people are happy. But technically, log is ln in Wolfram world. But yeah. And then this is yeah. So if you want to see how I did that, sorry, let me just show it to you motion because it's a good point. So this is negative. So integral of 1 over x dx is ln of x, and then it's bounded from n to n plus p. You remember, like, we plug this in, and then we subtract it from this being plugged in. So that's gonna be negative ln of n plus p minus ln of n. And then remember, for log rules, if you have logs subtracting each other, it's the same thing as a single log dividing. So that's negative ln of n plus p over n. Yep, cool. Awesome. All right. Yeah, always ask me if I'm like skipping some steps that don't make sense. Like, let me know. I'll do them. I always hated when my professors would be like, "Oh, it's fairly obvious. The answer's just fucking 0." I'm just like, "What, dog? Can you just chill?" ln of n plus p over n. Okay, cool. So then we're going to take the limit as n goes to infinity then, yeah? Yeah, left as an exercise to the viewer. Which is funny. You want dude, I did something. You want to see? I did something pretty funny. On my final exam I gave to my physics students, I had a question at the end just to like kind of make sure that they answered, like to make sure there were no technical problems. And here I'll show you what the final question was. It was pretty funny. And so the final question was like, what is Dr. G's favorite color? Sibley says that was the best question. Yeah. I wanted to, make you guys feel good, and also just to see like who's you know what was funny? Yeah, let me show some of the responses. Let me make sure I don't show people's names. But also like Albert's our TA. He wrote up the solutions manual for our exam, and it was pretty funny. The bottom here, he said, "You like this, Jeff?" He said, problem 14. I leave this one to the reader as an exercise. Like, what's Dr. G's favorite color? Let me see. I probably have the. You were so happy when you saw that? Nice. I forget if I can see the answers somewhere where they did, or say view. View freeze. Yeah, here are the answers that some of the students said. So most people got it right? Gold, 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 yellow, gold, 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 yellow, gold, yellow, gold like his stream background. Someone said blue. Who said my favorite color was blue? Purple. And then gold. Oh, this is, yeah, some people wrote some nice little things here. Black. Sorry, I forgot. Okay, that's okay. Green, purple. Anyways, yeah. I thought that was pretty funny. Okay, so yeah, not leaving this as an exercise to the reader. Now we take the limit as n goes to infinity. How do you forget? I don't know. Maybe they thought you're closeted blue lover who only presents as gold. Blue was my favorite color before gold chose me. Which then I think is very cool because UCLA's colors are blue and gold. So, yeah. So I actually, blue was my favorite color before gold. Okay. Okay, so as n goes to infinity. Okay, so we can just do this, right? So this is the same thing as negative ln, and we could say like n over n plus p over n over n over n. So that's the same thing as negative ln of 1 plus p over n. And as n goes to infinity, this goes to 0, right? So as negative ln is 0. Or ln of 1, sorry, which is 0. Nice. So 0 is less than or equal to this. Which, by the same token, is also less than or equal to 0. So this is equal to 0. The integral literally squeezed the two functions that both approach 0. It's a very fitting name. Yeah, the squeeze theorem is pretty cool, dude. Right. So we proved that this was equal to 0. For p is greater than 0, right? P needed to be greater than 0. Well, actually, did it? P could have been... No. Because if this was... No. Yeah, no, wait. Did P have to be greater than 0? I don't think it does. Yeah, I don't think so either. Yeah. P could be anything. Yeah, I agree. You just have to watch out for taking the ln of a negative number. But there's no way that P over infinity was going to beat out 1. Eventually, X will get big enough and overpower. Yeah, okay, cool. This is a cool question.
Well done! Well done!
All right. Motion. I will do yours and then Nick. Nick will help you out, and then we'll probably wrap the stream up. It's almost 7. Yeah. Let's see. Motion's back. All right, Motion, are you going to hurt me with this question, though? Okay. The diagram shows a hexagon. I mean, I guess this is a hexagon, technically. Looks more like an arrow tail to me. Blue is my favorite color when I joined UCLA. The gold didn't happen until probably my 6th year at UCLA, 7th. It's a Star Trek communicator, yes. Or isn't it where like this is blue and this is yellow? Is that like is that like the Ukraine's like army flag or something? I don't know. Okay. A, B, E, F are congruent. Okay, so these are congruent parallelograms. Let's like draw some stuff. All right, whatever. I'm just going to say they're congruent. So that means that this whole thing is equal to this thing, right? Because, yeah, C, B, E, D. Okay. AB equals BC, which equals X. Cool. I agree with that. This is X. This is X. P is a point on AF, and Q is a point on CD such that BP equals BQ equals 10. Oh. Did you go from Dr. Blue to Dr. Gold? So, I wasn't a doctor until I left UCLA. So, I actually, like, gold was my color, but I didn't call myself doctor yet because I wasn't a doctor. I didn't have my PhD yet. I honestly had, like, a lot of doubts during my PhD that I even wanted to finish. But eventually I was like, nah, dude, I need to be called Dr. Gold and, like, actually be able to say I'm a doctor. So, I did. And I'm glad I did. Glad I stuck it out. Grad school is rough. It's not for the faint of heart at all. That's why I tell people you got to really, like, ask yourself if you want it. I eventually just wanted it for the name. You can't integrate the square root of tan x. I don't know how to integrate the square root of tan x either, dude. It's kind of a weird one. Given the angle of ABC is 30 degrees, why is congruent equal and similar equals a bigger version? My degree's in plasma physics. Similar doesn't have to be bigger. Similar could be smaller. Yeah, I didn't go to evil medical school for 6 years to be called Mr. Yeah, it's when people call me Mr. Gold. I know it sounds pretentious, but I always tell them, I'm like, I didn't go to grad school for 9 years to be called Mr. Again, like I said, I took my time with grad school. Actually, honestly, what happened is my thesis project got switched at year 4 because I was going to graduate too quickly. And my advisor's like, oh, maybe you should check this thing out. And then that ended up taking like another 4 years. So, and then COVID happened, and like no one wanted to do shit during COVID. So I like took my time. Do you think it's worth it to do an undergraduate in physics at a university? Yeah, physics is great. It's a great degree. Apparently in the US, it's one of the highest unemployed degrees. I don't understand that. Y'all see this graph? One second, I'm going to show it to you. Highest degree unemployment. It's so bad. Where was it? Yeah. This makes me sad. Can I visit this? I gotta go to Facebook, yeah. Let me just watch the image, please. Thank you. Yes. The worst college degrees for employment in 2025. Physics. 7.8%. But also, like, computer engineering is at 7.5%. The reason for this, right, is that computer engineering, for sure, has been seeing a massive, like, clawback of jobs. Like, if you were getting any sort of coding job back in, like, 2012, 2014, even in, like, 2020, there were so many openings. People were hiring like crazy. And unfortunately, in the last year or two, everyone's getting fired because we're realizing we kind of overhired for these things. I don't know about the physics one. The physics one kind of boggles my mind. Math would be higher, but no one majors in it. Yeah. Well, it's an unemployment rate. So I don't think it matters about the absolute number, Jeff. That could be true as well. They're just self-employed and make bank. Yeah. Yeah, because they talk about career income, right? Career income's high for physics, 100K. That's pretty good. But yeah, you know, I mean, these I understand. I understand why, like, a communications degree or, like, you know, poli-sci. That's just, I don't know. Poli-sci's a cop-out degree people just get because they're in a frat or something. Would you ever be a quant? No. Trust me, dude. I had one of my great friends from we knew each other since, like, middle school. We actually went to UCLA together for grad school. He went into chemistry. I did physics. By year 2 of his PhD, he dropped out and went into investment banking. Now he makes like $600K a year. Makes a stupid amount of money. But I don't think he's happy. You know, he's buying his Porsche. He's got his Rolex. Blah blah blah. But, like, he doesn't look happy. But yeah, quants is it's an option for sure. It wouldn't be for me. Also, I think quants is something that's about to get, like, taken out with AI for sure. They have, like, some tests showing that you know, ChatGPT controlling a stock portfolio can beat out almost anything at this point. Okay, prove that the cosine of PBQ is equal to this. Okay. All right, let's try to get that. So I think I want to use law of cosines here, man. Yeah. So what is law of cosine? Sorry. It's like c squared equals a squared plus b squared minus 2ab cosine c, right? Quants is an option. Yeah, sorry, my bad, Roman. Yeah. You know what it is? It's because I have another screen here that like TikTok is showing, and like I see my TikTok screen, but I need to look at that one. I have so many screens in my dungeon studio at this point. 1, 2, 3, 4, 5, 6. I should be a quant. I have enough monitors to be a quant at this point. Isn't there an integral that's good for arbitrary points, so good for gambling? Yeah. Yeah. Don't worry, I'm roasting in here. It's like 85 degrees. Okay, anyways. So I think this is the law of cosines, right? And so if this is my triangle, that tells me that cosine of PBQ, which is equal to this mess. We'll see what comes out of it, but okay. So cosine of C is equal to C squared minus A squared minus B squared all over negative 2AB. Yeah? I already have A squared and B squared. Those are 10, right? So my triangle BP and BQ are both equal to 10. Yeah, I mean, a lot of problem solving is kind of just writing down what you know and seeing if it applies. This is probably, you know, this could be like the absolute wrong way to solve it. But I think I'm okay. But yeah, just write down what you know and just see if it works out. So A squared is, you know, so this is minus 200. Oh, I already see my mind. I already see the 200, right? And then this is all over minus 2, 10 times 10. I did think of the cosine rule. That's cool. Okay, so yeah. So I get cosine of C is equal to PQ squared minus 200 all over 200. Okay, so all that's left is to figure out PQ. Interesting. Oh, I can assume that PQ is the same thing as AC, right? How do I remember? I've just done it a lot. You know? It's the same way, you know, if someone says, how do you remember how to speak Spanish? Or how do you remember... You tell them, well, I did a lot of it at one point, so it kind of never left. So, yeah, I've been doing this for a while. Oh, okay. Wait. So, if PQ is the same thing as AC, then this is kind of a triangle, right? Fuck. Do I know that that's equal to X, though? Oh, wait. Whoa. I know this is equal to 30 degrees. Wait, right? Did we say that? Angle ABC is equal to 30. Yes. So that tells me that this angle here is 60. No. Wait, 30 degrees. This has to be, sorry, 75, right? ABC's is, yeah, angle ABC is 30 degrees. So this has to be 75 degrees. That's kind of an ugly number. I guess I could use the cosine rule again. Right? Yeah, I don't want to do the cosine of 75. Let me do the cosine rule again. But now we're going to do it for this triangle. This is actually really... this is a cool problem, man. Motion. Good job. This is a cool one. Let's look at this triangle. In that case, we have that the cosine of we have that PQ squared is equal to x squared plus x squared minus 2x squared cosine of 30 degrees. You gotta do this on an exam? That's kind of rough. Yeah, this is another law of cosines. So, PQ squared is equal to 2x squared, 1 minus the cosine of 30 degrees. Cosine of 30 degrees is square root of 3 over 2. So 2x squared, 1 minus the square root of 3 over 2. Okay, and then I think we plug that into here. Meow. Very cool. Okay, so then cosine of c is equal to 2x squared, 1 minus the square root of 3 over 2, minus 200, all over 200. Which, I mean, are we getting kind of close? We're getting kind of close, yeah. So, I'm off by 1. Oh, but we're going to switch this. I see what's going to happen. Oh, that's cool. I think so. Yeah, okay, I'm going to distribute the 2 in. So I get x squared, 1 minus the square root of 3 over 200 minus 1, right? Which I can then make this 1 minus negative no, yeah, 1 minus, wait. Fuck. I have a minus sign wrong somewhere. I don't like this. Oh. No. Minus minus divided by. Yeah. Cool. This is minus 200. Oh, man. Forgot the minus sign. There we go. Plus 1. Cool. There we go. So then if I want to switch the order of this, this is the same thing as 1 minus x squared square root of 3 minus 1 all over 200. Which is... Wait, this was a 2? I'm making all sorts of messy stuff today. Wait. No. Oh my god, okay. One sec. We got it. I have minus signs going all over the roof. Okay, here we go. X squared, 2 minus the square root of 3, all over 200. Yes, and then we're done. Oh, thank you, dude. You sent a heart puff. Love that. Thank you so much, Motion. That was a cool question, man. I learned some stuff from that. I learned I can do law of cosines, which is cool. Okay, cool. This was a cool question too. All right. Oh, why is my Twitch chat not showing? One sec. Yes, C was the angle between... Wait. C was the angle between... was between here, though. It was in between the line PB and QB. Dr. L. Nice to see you, by the way. Yeah. Yeah, this was a cosine of PBQ, which was this angle. I would imagine, yeah, this is kind of a different, this is, what exam was this for, Motion, by the way? What exam was this? And then Nick, here, let's do some of yours. All right. Oh, IGCSE Ed Excel. That's cool. Go look that up. Nick, what question you want to do? What are we doing this time, Nick? Why'd you create an alt in the server, dude? Oh, he says give me a second. Okay, cool. I'll give you a second. Let's go look up what this thing is. What? IGCSE Ed Excel. International GCSEs. Oh, okay, cool. We had another student, or a sensation. He's not really a student. Well, everyone's a student. Which, yeah, I remember you giving me some questions similar to this in the past. But he was studying for his GCSEs. Interesting. Pearson.
You.
What's up, dude?
What?
Oh, you do differentiation. That's cool. All right. Let's see. What did we do last time? We did like the prison system or something, right?
Yes.
Yes. Okay. All right. Let's do these. For those watching, Nick is a longtime student in the server, and he's studying for a government exam to become a court officer. So this, I always love going through these questions because it's just hilarious to see what the U.S. government like puts on its aptitude tests. They're quite funny.
Yeah.
Motion, he's slamming the like button. Only the first derivative. Oh, okay. Nice. He says, yeah, let's get those likes up. All right, let's see. Questions 1 through 5. Forest City, in imaginary jurisdiction, classifies its offenders as juvenile delinquents, youthful offenders, or adult offenders. I don't know if I want to call someone what's a youthful offender? I would just say youth offender. Why would youthful? It's like a compliment. A court officer, Drew. So I think it's like someone who's in the court, like making sure people like don't do bad things in court.
Yeah, inside the courtroom, protecting the judge or whatever.
Yeah. Unlike that one dude who like jumped at the judge like over the thing.
I like how he jumped her, went to jail for it.
And then he went back to jail again.
No, he went to jail for the. I don't even know. Whatever. A week or two later, or whatever, he had to go back to the court because he didn't finish. He jumped on her, and then they restrained him and sent him away. They came back.
Or he came back with like a face mask or something, right? Because he'd want to like spit on people or something.
Oh no, he came back to the same judge that he jumped.
Yeah.
I don't know why they didn't change the judge.
Well, you know,
he went back to her.
Yeah.
To jump her again.
Never back down, dude. Never back down.
Yeah.
All right, let's see here. Table A shows the average number of daily inmates for the years. Table B shows what percentage of average daily numbers of male for the years were juvenile to. Okay, cool. So this is saying inmates were this. Oh, and here's some missing things. Wait, what was the first question? Sorry. From 1990 to 2000, the average number of female youthful offenders in the Pleasant. Okay. Okay. Wow. Okay. So we got to do some math here. So 20% in Pleasantdale. Okay. This is a lot of just like seeing things. So 20% there, 25% here. And then we got to look at like in Pleasantdale how many inmates there were. Okay. So there was 70 here, and then there was 105 here. Yeah. Okay, so we want the number of youthful. No, sorry, youthful offenders is the B code. Oh man, this is a lot of just like reading tables. Okay. So out of the 70 female offenders in 1990, 60% of them are youthful offenders. So you're going to do 0.6 times 70 plus this is going to be 0.75 times 105. Because then this is the youthful female offenders in Pleasantsdale in the year 2000. And then you want to average these two. That's what they want. They want the average. And is this all daily? Average? Yeah, this is all average daily. Now you got to worry about like if the time is correct as well. Okay, cool. So this is going to be 42. This is going to be about 75. I guess it's like 78, technically. Here, we can pull a calculator out. 0.75 times 105. 78.75.
Damn.
And then you just average these. So this plus 42 divided by 2, 60. So a figure greater than 40. I wonder if I had to do all that math. I mean, I guess I could have seen that, right? If this one is 42, and then this is greater than 42, the average is going to be greater than 40. Yeah. Duh. Okay, cool.
I'm gonna take the book. Give me a second.
Oh, do you have the answer?
Yeah, I'm gonna find it.
What are the percentages for Drew? Yeah, so they're saying that for a certain prison, these are the percentages that are classified as either juvenile delinquents, youthful offenders, or adult offenders. And then this tells you how many total inmates were at Pleasantdale that were also female. So if you want female Pleasantdale 1990 youthful offenders, you have to do 60% of this number up here. But yeah, Motion, you can also like figure out, this is pretty easy, right? So this total, it is lots of reading and checking and going back and forth. Agreed. Yeah, it's kind of annoying. So this has to be 125 if that adds up to 195. I don't know how we're going to get Y and Z here, actually. This is not too bad, though.
It's not a figure greater than 40.
It's not.
It's 37.
The fuck? Female offenders in Pleasantdale is 70, and 60% of that 70 are youthful offenders. So that should be 42. And then in the year 2000, 75%. Oh, I see. They're saying the average increased by. Oh, that's dumb. Sorry. Yeah. Okay.
So it's 78 minus 42?
Yes, it's 79 minus 42, which is equal to 37. Okay, I read the average thing wrong. Yes, I don't think you have to do the average. I agree. You didn't have to do the average. You just need a different... Oh, one sec. I gotta reload us into this. We went over the 3-hour mark. Did we? Or 2-hour mark?
Yeah, 2.5.
2.5. Where's my password? There we go. Okay. Okay. All right, we got that. Okay. See, I just read the average, and then it mostly... I thought it was just the average from 1990 to 2000. Not that the average increased by. So you have to be tricky. You got to read the whole thing, apparently. Okay. Which of the following sets of belongs in the, for Y and Z? Ooh, okay. Shit. Okay. Well, I know I need all of these numbers to eventually add up to this, right? So we're going to figure out what y plus z needs to equal to. So y plus z must equal 50, 30 minus... let me use a different color. Y plus z must equal the 50, 30 minus 1700 minus 1850 minus 310. Exactly. Very good. Very good. No, you got it, Drew. So, let me get my calculator out. Sorry. 50, 30 minus 1700 minus 1850 minus 310. So y plus z has to equal 1170. So let's look. Which one of these adds up to 1170? Not this one. I think only this one, man. I think it's just D.
Yeah.
Nice.
So there's no way to actually get 120 and 1050.
No, you can't get the actual number. No.
Oh, okay, okay.
No, you can't. W and X. Well, we already know W is 125. So then X is 125 plus 3920. 125 plus 3920 is 445. 4045. Fuck. No. Wait, what?
It's 3,920.
Oh, my bad. My bad. Yes, it's
190.
this plus this. Yes. Okay. So that's like 4115. So I think it's A. Yeah?
Yep.
Nice. Cool. In 2000, the percentage found in Maxim... Okay, in 2000... Out of all the males and females, what percentage were found in Maxim? Oh, okay. Well, Maxim only had male people in it.
Yeah, that's what confuses me.
So I think it's 1700 divided by 5360. So 1700 divided by 5360. 30. Ooh, I don't like that. I don't like that. 1700 over 5360, yeah? It's closer to 33. Is the answer C?
Yeah.
That's kind of garbage. It's so close. Because 31.7% is like almost exactly halfway between 30 and 33. Okay. In 1990, the average daily number of adult male females... The average daily number of adult male offenders was most nearly. Oh, okay. So adult male is C. Oh, man. Sherman and Thompson. Okay. Ew. Sherman was 55%. And sorry, what year? 2000. Of 110. 55% of 110 is basically 60. Yeah, 60. Okay, so I agree with 60 in Sherman. They're going to probably screw us here with the Thompson one. Thompson is 60% of 650. 390. Yeah. Oh, actually, choice A is good. Yeah. Is that right? Choice A?
Yeah.
Nice. Sick. All right, I'll send you this.
Thank you.
Yeah, I just had to do it. Yeah. All right, let's see. Any other last minute questions before I wrap up the stream? Doesn't look like it. Okay, cool. All right. We'll close it out. All right. Thank you, everyone, for coming to Actual Education Office Hours. Really appreciate everyone who showed up. Thanks for... Maybe I will start streaming on Friday. I don't know. There seems to be a lot of people on Friday, and they need people to stream math. Maybe I might change the schedule. We'll see. I don't understand why the test makers don't make the numbers come out to rounded numbers. It does. Exactly, it does. Yeah, they should have made it something nice. Good job, Drew. Yeah, you'll get bond coins for that. Yeah. So our next stream is going to be on Monday. That's going to be at 3 p.m. Pacific, 4 p.m. Mountain, 5 p.m. Central, 6 p.m. Eastern. If you want to come by. Oh, good to see you, Omega. Yeah, if you're ever wondering about when we stream, I keep a pretty up-to-date calendar here. So I'll dump it here in the chat for you guys if you want to see. There's that. No time like the present. Yeah. So, when I couldn't stream on Wednesday, I made sure to stream on Friday as like a little bonus to you guys. So, but our next stream is on Monday. If you want to come play Jackbox games with us, we're going to do that on Sunday. I usually don't stream that because people say things that would get me banned on Twitch. But feel free, join our Discord, and we'll have like an open stage Sunday. That'll be at 3 p.m. Pacific. And for, yeah, any news on what's going on in the server, join. The link down there, the actual discord.com/submit, has all of our channels. So go through, like, subscribe, everything, and you'll get notified when we come back online. Do you know we are connected on LinkedIn? Maybe. Maybe we are, Roman. I accept any requests on LinkedIn. So I'm glad we are if we are. You're very welcome. Mr. AG, Mr. AU. AG Silver. Okay. All good. Good to see you too, Dr. Aldo. Let me what is Jackbox games? It's kind of like little like trivia games and stuff. They're fun. Come by, just come by the Discord. You're in the Discord, Drew. So just come by on Sunday. You'll see it. Okay. Mr. Silver. That's too funny. Who do we want to go raid? Let's go raid somebody. Go say hi to someone on Friday. There's actually a lot of people on Friday. Wow. That's great, actually. Good night, Chantrix. Good to see you. I don't know if I want to raid. I want someone who's doing science. I do like physics and depression. He's a G. Go say hi to physics and depression. Oh, he's doing resistor circuits. Yo, Sib, if you want to see like some crazy resistor circuits. Yes. All right. Enjoy your Friday. Enjoy the weekend. We will see you on Monday. Peace.
I have suggested that it may be that that Kirchhoff's major contribution was not just writing down, hey everyone, I want to announce to the world that energy and charge are conserved, which probably was reasonably well